Hello, today we will look at a special application of nuclear magnetic resonance in product development. Microwaves extend from 300 MHz to 300 GHz, and the microwave testing is just non-destructive testing using frequencies from this part of the electromagnetic spectrum. Nuclear magnetic resonance can be treated as a special variety of microwave testing because NMR uses also these frequencies. We have learned in an earlier video the basics of NMR, and today we will look at a very special application in product development, namely in the research and development of batteries. We will have to excuse for the bad sound in the beginning of the next video. So let's go.
Lithium battery electrolytes, where obviously you are likely to have lithium, but we can understand the carbon spectra, potentially boron, as you may have some boron containing salts, but even potentially different battery chemistries in entirety. So things like sodium are also possible to measure on a single instrument. And now I'm going to hand back over to Robin, who's going to show you just how simple it is to make those measurements on an X-pulse.
Thank you very much, James. You can see in front of you SpinFlow, which is our data acquisition software with the X-pulse. And you could also see in the top right-hand corner of your screen details on the sample currently inserted in the system. So this is a pseudo-electrolyte system. So it is a mixture of dimethyl carbonate and ethylene carbonate, containing both lithium hexafluorophosphate and a small amount of sodium tetrafluoroborate. Altogether, this gives a total of 7 NMR active nuclei within that system. Indeed, the oxygen in the carbonates, in the alkyl carbonates, is the only only nuclei which cannot be observed by the X-pulse. To give you an idea of just how easy it is to perform these measurements in SpinFlow, we can look at obtaining a proton NMR spectrum using our standard, quick, 1 proton custom NMR spectrum, which will collect 4 scans over a period of just over a minute. And as we can see here, the spectrum is immediately loaded into Mestranova. And once we zoom in, we can see 2 very clear, very distinct signals corresponding to the protons in dimethyl carbonate at 3.7 ppm and ethylene carbonate at approximately 4.5 ppm. As we can see, as James said, these signals are inherently quantitative and can be integrated to see, and then from which you can then back calculate the exact ratio between the 2 components.
That's it for today. Thank you for watching. Goodbye.